Hi everyone. In this session, we are going to understand some very important questions of Surds. But before that, we'll also understand the fundamental topic of Surds, which is rationalization. Rationalization we do just because we need to get rid of the root from the denominator. And here, as you can see, under root of 2, I need to get rid of this under root from the denominator. Now, how can I do so? That's the question. Well, however, there is a possibility that I am just going to square the root 2n and get rid of the under root, but that's now how maths works. I need to maintain the synchronicity of the equation or fraction, whatever I'm taking, right? So to do so, I will have to apply a proper criteria and follow a perfect rule for it. So when I have to square the square root, what I have in mind is I'll apply the a square minus b square identity, which will help me this in the squaring of the root 2, and thereby it will also square the 3. So here you can see that a square minus b square is a minus b times a plus b, and a plus b is already with me. What I'm going to do is I am going to multiply this fraction with 3 minus root 2. Now am I only going to multiply the denominator? No. Whatever I do to the denominator, I will have to apply the same to the numerator as well in order to maintain the synchronicity of the fraction. That whole answer doesn't get deflected. So we have to multiply the same with the numerator also. So 3 minus root 2 on the top divided by 3 square minus root 2 square in the denominator, which will yield 3 minus root 2 upon 9 minus 2, which is 7. So 3 minus root 2 over 7 is the answer. Next question. Again, I have this in the form of a minus b. So I will multiply the numerator and denominator by root 41 plus 5 over root 41 plus 5. So I will have 16 times root 41 plus 5 divided by 41 minus 5 square, which is 25. This will yield 16 times root 41 plus 5 divided by 41 take away 25 is 16. 16 and 16 can be cancelled because both are in numerator and denominator, and 16 exists with both root 41 and 5 also, so we can cancel them out, and the final answer that we are left with is 41 or root 41 plus 5. Let's come to the next question. Now here there are two types of fractions given, and both of them have to be added. This has to be simplified. So first we'll start from this right one. As you can see that it is in the form of 1 upon 2 minus 1 upon 3. In the fractions, what do we do when we have the co-prime numbers on the either side? So we multiply them together, make them 6, and then 3 is multiplied to the numerator 1, so 3. Take away 2 multiplied to 1 is 2. The answer is 1 upon 6. Same is what we are going to do over here. 2 plus root 3 times 2 minus root 3. And the numerator will carry 2 minus root 3. Take away 2 plus root 3. Always write this bracket whenever you are having a negative sign. That will help you solve it clearly. So 2 minus root 3 minus 2 minus root 3 divided by, now a plus b times a minus b is a square minus b square. So we have a minus root 3 and minus root 3, that will be minus 2 root 3. But we have a plus 2 and minus 2, that will cancel out each other. So the answer is minus 2 root 3. Same we are going to do over here. Root 3 plus 2 times 2 plus root 3. But this is unfortunately not in the form of a minus b times a plus b. This will get me 3 roots in the denominator, which I would not suggest to do. What rather I can do is I can rationalize the first fraction, that will be root 3 minus root 2 on the top divided by 3 minus 2 in the bottom, which will be root 3 minus root 2 over 1. Then we have 1 upon 2 plus root 3. Again, rationalize. 2 minus root 3 over 2 minus root 3. That will be 2 minus root 3 upon a square 4 minus b square 3, because root 3 square is 3. So this will be 2 minus root 3. Now simplify. Root 3 minus root 2 is for the fraction first one, then plus 2 minus root 3 for the second fraction. So we have a plus of root 3 minus of root 3, cancel them out. So the answer is 2 minus root 2. This is how it is to be done. I would suggest that please you can try it by yourself after pausing this video at this moment, and only then proceed to the next question. Okay, now in this one we have to find out the square root of 7 plus 4 root 3. How do we do so? So if I have to find the square root of any number, I need to first write it down in the form of either a plus b whole square or a minus b whole square. A plus b whole square is a square plus b square plus 2ab, and a minus b whole square is a square plus b square minus 2ab. Let's see if I can write this as any one of them. So I can write 7 plus, now 4 root 3 can be written as 2 times 2 root 3. I would suggest to get rid of any other thing that is apart from 2. So take it inside of the square root. This will become 7 plus 2 under root of, if 2 goes inside of the root, it will become 4 times 3. Right? Now we have in the inside 2 root 4 root 3, which is 2ab. Can I also have 7 in the form of 4 and 3? Of course. So 3 plus 4 plus 2 root 4 root 3. So 3 plus 4 can also be written as root 3 square plus root 4 square. Correct? So now we have finally got root 3 square plus root 4 square plus 2 times root 3 times root 4, which we can write as root 3 plus root 4 whole square. That can also be written as root 3 plus 2 whole square. This is how you find the square root of 7 plus 4 root 3. Let's catch up with the last question of this session. Square root of root 48 and root 27. Now I need to find out the maximum perfect square that 48 can have. So 48 can have as 16 times 3, because 16 is the max perfect square that 48 can have. Take away 27 can have 9, because 9 times 3 is 27, so 9. Now if we will bring these numbers out, we will have 4 root 3 minus 3 root 3, which is root 3. This is the square root of root 48, take away root 27. That's it guys. I'll see you in the next class. Take care.